In this video, we're going to be talking about function notation, but let me just first talk about the point of this unit. So this is our unit 7, which is just the fall review. So for each unit that we've had, it's been broken up into like little individual lessons. We're kind of learning small stuff at a time, and we kind of put it all together in a unit. And then over the course of the semester, we've learned different units. And the point now is to put all of that together into our kind of overall fall review. So we're kind of connecting everything we've done throughout the semester into a single set of videos and lessons. That way we can review everything and make sure we kind of know the big topics, and you can kind of see what's the most important things that you learned throughout the fall. So in this one, function notation, we really are interested with functions when we're talking about algebra in your future math classes, so we seem to be good with working with functions. So before attempting this lesson, just make sure you can go back and talk about the coordinate plane, reading tables, and the order of operations. We're kind of going to go through all the basics of function notation, so you don't need to review all of that. It's kind of the things you need to know before function notation are those things. So in math class, we're primarily concerned with working with functions. So this is the really important things that we're working with functions and what's special about a function. So you can talk about the relationship between different things, how different things are related. But a function is just a special type of relationship where we're putting in something. We're going to put in some input. And when we put in this input, our function tells us to do something. And the important thing is we get one thing out. So the way I like to think about it is if I put in some number, I'm only going to get one other number out. Functions don't always have to be numbers. That's kind of one thing we get focused on too much in math. Functions, you could put in things like an apple. You can get out how many calories it is, but I'm just getting out one answer. So the important thing is whenever I put in one thing, I just get out one single thing. So what is function notation? Function notation is just a way to simplify the process, saying, oh, okay, well, I put in 3 into my function and I get out 5. So that's like a phrase you would say, I have this function, I put in this number, I get out this number. But we want to simplify that process and not have to write out a full sentence. So the way we do that is f is our function name. So we're just going to give our function a name, generally just a single letter because it's easier to write, but we'll see in trig and things, we have like sine of x. So sine is the whole name of the function. And that's our function name. The thing in parentheses, this is our input. So we're going to put our input into our function, and then we get an output. So for the example I wrote up here in words, that would be f of 3 equals 5. I put 3 into my function, and that gives me out 5. So that's the basics of function notation. We also learned inverse function notation. Inverse function notation is just doing the original function in reverse. The notation is we just put this little -1 right next to our function name. And that little -1 just says you're doing it in reverse, you're doing the opposite of what you did before. And the important thing with inverse function notation is if I put in a value into my inverse function, that's the value I got out of my original function. And then the thing I got out was the thing I put in. So in my original function, these are like our x and y values. So we're kind of thinking of these, in reverse from our original function. So here's the 3 different types of function notation you need to be able to use: graphs, tables, and expressions. For all of these ones, you've technically already kind of learned how to do these problems at some point, so you can pause the video at any time and try these problems on your own first to kind of see, like, do you remember this from when we did it earlier in the semester? If not, that's why we're reviewing. So we know that all the important stuff. So here we have this function, and we find f of -2. So the important thing, the thing is in the parentheses, is our x value. So we're going to find x is -2. That's that value there. This is all the stuff that has -2 as an x value. Because it's in that x equals -2 section, but it only hits my graph in one place, and the y value of that one place is 6. So this is going to be equal to 6, because that's the y value that's paired with that x value. F of 4, again, this is x, and we have this point here. This point is 4, 0. So whenever we have a point on our graph, it's input, comma, output. So if my input is 4, my output is 0. F of -9, again, at any point, pause it, just kind of quickly see if you get the right answer. F of -9, -9 is my x value. I see where that x value hits my graph, and it happens there, and that happens at the y value 5. So it's going to be equal to 5. All right, so all those are the same. You look at your x value, see what y value corresponds here. It was 0 because it goes straight down to the y value 0. Right. Now what about f inverse of 9? I remember the inverse we're doing opposites. So all of these were x's and y's. Now this is going to be a y value. So this is 9 on the y-axis, which I go to there. Let's do it in a different color, in yellow. And these are all the values that have a y value of 9. And you see that hits my graph in one place right there. And that one's x value is -5. So the answer for this one is -5. And another reason for this is if I switch it to the original, f of -5 is 9. So again, whenever you switch between the inverse and the original, those things just switch places. All right, next is a table example. In my opinion, tables are the kind of most straightforward one because you're just looking kind of straight up or down the table. We have our x values on the top and g of x. Remember, those are equal to our y values on the bottom. So g of -2, we look at x is -2. That happens there. We plug it into our function. We just go straight down, and that's -5. Right, so we get -5 for g of -2. All right, g of 8. Again, see if you can guess the answer. G of 8, that's our x value. The y value is 2. So that gives me 2. G inverse of -8. All right, so now we're doing the inverse. All right, that's the kind of important part. So this is our y value starting with the output -8. And that gives us the original input 1. And we always check our answers right with an inverse by doing the original function, making sure this makes sense. And it does, because if I put in 1 into the original, I get out 8. And that's one, g inverse of -2. And -2 is the output. Oops, there. And that gives me the input 10. And that's because g of 10 is -2. All right, so you don't have to write what I wrote on the bottom. You just have to say the answer. Just those are the answer. All right, the last thing we're going to do is looking at expressions. Again, the whole thing is we're putting in an x value into my function. So if I have -3 and I'm going to put it into my function, I'm going to put it in for that x, which means I'm also putting it in for that x. So the basic idea is when you're doing function notation with an expression, you just plug it in for x. And just make sure you're always careful. When you're plugging stuff in, you're using your parentheses to kind of separate it away from stuff. But here we get -15 minus 3 is -18. Here we have h inverse of 7. All right, so h inverse, remember this is the y value. And h of x is the same, is equal to y. So we know the y value over there is 7, but we don't know the x value yet, right? Then we ever do the inverse, the thing we're equal to is the x value. So we have to do a bit of solving here, adding 3 to both sides, and then dividing by 5. So we get 2 for our final answer here. All right, that makes sense because if I put 2 into my original function, I would get out 7. So I'm going to inverse. If I put in 7, I get out 2. All right, the last one, all right, just another example of using an expression. Again, pause the video if you want to try these on your own before I go over them. The only difference here is we have multiple x's in our expression. So we've got to remember to plug this 2 into both of them. All right, so we're going to put 2 in for both these x's. Now we're going to look like 3. Again, always use your parentheses when you're putting stuff in so you do the order of operations correctly. First thing we do in order of operations is the exponent. So this is going to be 2 squared is 4. Then I can do the multiplications. And then do addition and subtraction left to right. So 12 minus 6 is 6. 6 plus 1 is 7. F of -1. All right, now we're just putting -1 in for x. And be really careful with your, especially when you're putting in a negative, always use your parentheses because sometimes you might confuse it with a minus sign instead of a negative. But they're negative signs. -1 squared is +1. Right, making sure you do that exponent first. This is probably one of the most common mistakes that people make on a problem like this is just messing up the negative there. Multiplications. Again, this is turning into a plus because there's a minus there and a minus there. And this gives me 8. So my final answer is 8. All right, so that's all the review of function notation, or those are all the function notation types we learned. As long as you can do with a graph, a table, plug it into any type of expression, then you can do function notation. All right, so for the review unit, you're not going to have to complete individual skill checks because you find it already showed by doing the skill checks before and the test that you can learn this topic, and that's kind of what the skill checks are there for. But now we're kind of reviewing and making sure we go back and remember these things. So instead of doing the skill check, you just have a list of practice problems, and I would say do all those practice problems to really make sure you understand function notation in all its forms, and that'll prepare you for the semester exam. I also, for all of these topics in Unit 7, the review, I'm going to include a 7+ unit. All right, so the plus just means they're going to be challenging problems, and we'll talk about those when we get to the 7+ unit. All right, but there's some extra challenge out there. If you kind of get through this review and you're really prepared for the fall exam, there's some more that you can do.